The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
There you go. I'll do the Vanna White thing. So this sucks in air here, and inside figures out the percent of methane or other combustible gases in it, and it sucks in about, I think, half a liter a minute. And so you can get the percent gas in the air. And so luckily at the moment, there's probably 0% methane.
Is that what gas companies typically use to find leaks?
Yeah, they normally have a big probe on it.
Oh, yeah.
And what they do is they they take a bang bar, which is like a big stick, and they stick it in the ground until they get a hole, and then they stick this with a probe on it, suck air in, and figure out what the percent gas is in the soil. Then they know, by where the highest percentage is in the soil, they figure, okay, that's probably where the leak is, and they start digging there. So it's a really simple and fantastic tool. CGI, yeah, combustible gas indicator.
And right here is where the inlet is. Okay, just off of here. We do this. It's better to do it than in the back bumper because there can be some exhaust contamination. Actually, well-tuned cars, we've tested it, do not interfere. But this is a little bit of an old van, so sometimes with it passed emissions test, but still there can be some contamination. And so that's why, when we stopped, sometimes you'll get some measurements. But when you're moving forward and the wind is upstream, then there's, you get readings. This is the methane reading that the analyzer is reading right now.
Yeah.
So it's anything below 2, it's right now 1.96. is pretty clean. There's no leak where we are right now. So if it's under 2, we're in a place with no leak. And even if it creeps up over 2, if it's like 2.01, 2.02, that's not really indicative of a leak. But if you see it go up to like 2, you'll see your eyes can tell you in time that it seems to be going up pretty rapidly here. And so, you'll see it maybe go up to 2.3 sometimes and then drop back down. And that's kind of unusual. That's like, okay, there's probably something around here. And then every once in a while you might see something that goes up further, 3, 3.5, and those are like definite leaks, So
What's the highest number you've ever seen?
Well, in DC we got, I think very near to 100 parts per million.
Wow.
And that's in the air that we're breathing, right? So it's not explosive at that level, but it's like 50 times more than the background value. Okay.
So 2 is baseline kind of background?
Yeah. You can consider 2 to be a baseline kind of level. Now it's like CO2 used to be 280 parts per million, and now it's like over 400. So 2 parts per million methane is the new normal. I mean, it was 0.7 parts per million pre-industrial. So I always like to point that out, that our normal baseline is very abnormal. So we're going up above that with leaks. Now this is a timeline here, this graph, and you can see as I came in here, we did get 6, 7, we got a few leaks here. That was right at the Alston-Brighton tolls coming down off of the Mass Pike. There's a leak there. So
So what happens in terms of reporting that or following up with it?
So we don't have any evidence, but based on driving by, we can't say whether it's a grade 1 hazardous leak, a grade 2, or a grade 3 so-called non-hazardous leak. So I don't feel obligated that each blip we see that, okay, we got to call the gas company. First of all, they know, they do know about these leaks. They know for to a large degree where they are. But if we get out, and we could because we have the CGI, if we decide to get out, and poke around and look for one, and we find evidence that it is like a grade 1, then that's when I feel obligated to call the leak in. Because, you know, it's like we have knowledge that something it could, you know, seems to be unsafe, and so, and we call it in. Yep.
Is there a clear indicator when it's a grade 1?
This machine is not going to be able to tell us whether there's a grade 1, grade explosive hazard, grade 2, or grade 3. You know, that's because you can have big leaks with lots of gas coming out that are not explosive hazards. That's like the Porter Ranch gas leak in LA. Audrey makes this point a lot. It was technically a grade 3 non-hazardous leak because it wasn't going to explode, you know, and it was that close to the neighborhood. It was like a quarter mile away from the neighborhood. So it's an indication that that grading scheme is only a single variable grading scheme, and you know, explosion and hazard is a big deal. There's no doubt about that. No one wants that. So, but the grading scheme has to, you know, incorporate the amount of the flux. There is a GPS on this roof right now, and it's plugged into the back of this machine, and the data file that comes out is already integrated with GPS.
That's pretty cool.
With the timestamp.
Nice.
Straight?
Left.
Left.
If we can, yeah. So what are the objectives for today? Is it just to see how methane is measured? Or are we trying to answer any particular questions?
So what we call this is a gas leak safari. So one of the objectives, okay, here we go, 2, 3, 2, 3. So there's something there. So to educate and to show, first of all, what this process is of mapping the gas leaks. I think that we're going to places that we have surveyed in the past. Audrey and Heat did the study now 2 years ago, is it?
Yeah, I think so.
But things change.
Right on.
Take a right here.
Right on Portland. 2.1, so 2.1. Okay, here we have something. 2.2. So there's something here, I think.
2.3.
2.5, 2.7. Okay, yeah, read them out.
2.8.
2.8.
Okay, so there's a leak here
2.4.
in this vicinity.
2. Portland and Maine. 2.3.
3.3. Well,
Okay, here we go.
4.4.
4.4. 4.2. 3.8.
3.8.
So you can see there's the spike on the leading edge.
How far do you think it's drawing air from?
Right. So
right around the bubble.
it's really, as you can imagine, as any layperson can imagine, the vagaries of wind are going to carry the plume. The plume is coming out of wherever it can come out. It could come out of a manhole slot, straight on.
Straight on.
It could come out of soil. A leak is going to just find whatever parallel pathways it can get out. And so you can imagine at the surface there's, you know, some kind of profile of this stuff coming out, and then the wind's going to carry it and blow it around. And so that makes it a little tough. We can't really pinpoint exactly where it's coming out of the ground. We can know when we have driven by. There's a leak in this vicinity, and I would probably say within 50 to 100 feet of where we measured it is probably part of the source coming out of the ground. But to actually really pinpoint where the pipeline leak is would require us stopping, getting out, and using the instrument that Audrey has, as well as maybe some other instruments, handheld sniffers, to really, find out where it's coming out. What you're realizing right now that makes it like discrete when we see a leak, if you look at this timeline here, this trace, you can see that there's a lot of flat and then some fairly well resolved spikes. And so it's not very ambiguous when you get an elevated anomalous reading. It's like, oh, there's one, there's one, there's one. Here's a couple that are small, but they really do stick out very clearly from the background. So there's not that much ambiguity about, like, well, is this kind of giant blob, a leak or not. They're well-resolved spikes in time and space.
What's the biggest leak you've seen in the Boston area?
Maybe like 40 or 50 parts per million in the air.
Where was that?
I think, well, a couple places that were close to that. One was Rutherford, Sullivan Square, Rutherford Street in Charlestown, kind of on the Somerville-Charlestown border, the giant rotary.
Yeah.
I mean, we could go over there. There was a big leak there. And then Nonantum Road between kind of Watertown and Newton, 22, 23. Okay, so there's something there. Okay. 23. Okay, so we've got 25.
25, 28,
Okay,
3, 32, 4, 8, 6, 4,
Oh
6,
boy.
5,
Oh boy.
5, 3.
So,
5,
I mean,
4,
if
4.
we could like get out and take a break and find it if you wanted on this
sure.
one. It's kind of quiet.
I-
This is definitely a much blunter instrument than that one. And it's made to find out like percent level, 50%, 10%, not parts per million. Okay, so this is now when you want to find out where is it coming out, okay? And the professionals right now would have this bar, it's called a bang bar. It's like one of those construction pile drivers. It's like a handheld version of that. And you would find out, and you like maybe right here, you'd like slam it down, maybe some, up to a meter, and then this would have a longer thing, and you stick it in there. Now I don't do that because I'm not certified to do that, and I don't want to puncture any gas lines and create an explosion. So what I do is I just kind of do like this, and sometimes I'll use a like a screwdriver or just a stick even, and kind of this is right at the surface, and poke around. So actually, look, there is something 0.2 now the fact 0.25%. So 0.25% is let's see, 1% is 10,000 parts per million, right? 1% is 10,000 parts per million. This is 8,500 parts per million right now. 0.85, 0.9. Okay, so the thing is that this is right at the surface. If I was down even probably that much, it would probably be, I don't know, 15, 20%. And if we went down a little further, this could be 90, 50% gas. See, this is 0.25. Yeah, so about the same. I'm just like about that far in. But now this is an indication that there's definitely a leak here, and it's no mistake. We got the 15 parts per million in the kind of air that we're breathing. So now let's look around for just infrastructure. Let's see. I mean, we just came out. That was a very arbitrary choice of a place to look. It's just we got out. We're here. But now I want to see, like, okay, where's the gas line?
And all that.
Vestige of a gas marking, and this big patch has been, for some purpose, I don't know if it was a gas line. I see some more yellow paint out here. And okay, so this is indicating. Okay, yeah. Always be very careful with the cars, of course. So this is a service line coming off of the main. Okay, so service lines going this way, mains generally going that way. Mains can be at an angle. They can be running under the sidewalk. So it's anything can really happen.
So were mains laid down before the streets were gridded or something, or what?
Or sometimes afterwards.
Okay. But if it's afterwards, I'm going to assume that they're contiguous with the street.
Probably would do it running that way if it was done afterwards.
Okay.
This is an electrical manhole. Yeah, I see. The gas can come in any, it can seep in anywhere. Okay, so 0.25. Okay, so gas in there. All right, so we did this. See what we get up to.
You get the one and all.
Yeah. Okay, so, all right.
Twister.
So there's definitely gas in here. That's very, very clear. I mean, if you really wanted to, you could smell it and smell the gas, but I'm not going to recommend that. But this is not an explosive threshold. So I don't feel like back off, don't smoke or whatever. Well, don't smoke, but If it were 4%, then that would be a grade 1 explosive hazard. Okay, and we would call it in, and they would come out immediately, well, within a half hour or so.
And again, 4% is what on that readout?
40,000 parts per million. 4% is equal to 40,000 parts per million. So if this reads 4.0, that's 40,000 parts per million, and that's the lower explosion threshold. The higher explosion threshold is about 15% gas. If it gets above that, there's not enough oxygen, for it to explode.
Right, where little kids are like playing in the playground. There's a grade 1 leak under a manhole. We call it in, and these two guys from Eversource arrive, and they don't even have like a bang bar and like they didn't have the right instrumentation to do anything. And they pop open, so we pop open the manhole for them, and they look and they're like, yeah, and then we go off to the side, and they actually sat in front of me because I don't think they realized that I wasn't a utility person.
Yeah.
They're like, yeah, you just got to think sometimes, an explosion is price of doing business. And like the kids are like behind us playing in the playground. I'm like, ah!
It wasn't a facetious comment, huh?
No, it was
like,
like
it comes with the territory.
Yeah, and I mean, yeah, it was sort of in front of the kids. I just thought that was really strange.
So did they do something in the next?
They did fix it after a while. I don't know what Bob said, but they didn't fix it at that point.
That's the highest we've seen.
Yeah, one. It just exceeded 1.2. So the gas company. So two. Okay, so this is too close to this tree to be good for this tree. And clearly this tree it's not that old. How long ago did they put this in here? How much did it cost to put this in here? And now you've got a leak here, and this white paint. That's a sign of the gas company having been out here at some point to monitor. Here's the service line. So I don't know. I mean,
sorry if I missed this earlier, but why does the methane cause tree?
Oh yes, sorry. The methane, the natural gas has no oxygen in it, and the root systems need oxygen to metabolize. So you've got this plume of anoxic soil volume, and it kills the roots.
So in fact, right here, isn't it the case that there could have been an older tree the same age as these tall ones that died and was replaced by this? And possibly it died because of a methane leak?
Yeah, I mean, it would be very interesting to find out what the history of this is, because this is, I don't know, this is maybe 2-3 years old is my guess from the sapling, from the whenever it was planted. Okay, I'm not getting anything at the very surface here, but we definitely got some there, and that's too close to this tree, because I mean the root system is certainly going over there. Another really interesting thing, so it actually does come back to being, so I'm a tree physiologist, actually. That's what I'm supposed to be doing. That's why I got into this stuff. But it's interesting because some trees have a vasculature that is called segmented, and some tree species have an integrated vascular. What that means is that some species, the roots on this side are connected to the pipes that run water on this side and are connected to the branches on this side. And then this side operates kind of like as a parallel path. Whereas other tree species, like pine, a lot of the pine species, it's like whatever comes out of here or goes through here could have been from anywhere in the soil. It's integrated, okay, spatially integrated. So if the gas leak has some spatial pattern to it, you could see differences in where it shows up on the tree depending on the tree species and its vascular structure. Look at this. Look how it's breaking off. Like the twigs are just snapping. This tree's not in good. It's dried out, and so this is not. This tree is having problems. You can just. I mean, I'm not killing this tree. It's just like these tips are dead. They're not hydrated. So.
This one's okay.
Okay, yeah, so these are okay over here. This side is not doing so good. So I don't know.
So it's something that you envision citizen scientists doing, like coming, kind of measuring their methane and like trying to trace a problem their trees and then reporting it to the city or
Yes.
reporting it to...
Totally, yeah. And that's the whole idea behind making this available through heat by the Sierra Club. I'm on the executive committee of the Sierra Club, so I'm like, you know,
Totally
promoting the Sierra Club. But they're making these things available for communities to do what we're doing, to use your nose, use your eyes, to find, you know, if you know, people will walk by and it's like, ooh, I smell a leak. And then you can go and check this out and actually find out where it is and then report it, you know. You don't have to wait to report it. If you smell a leak, you can and should report it. But it empowers you to find out more. And Mothers Out Front has been like amazing in terms of also, you know, it's not just what they know, but when they plant that flag in the ground, it's showing everyone else that there's a leak there as well. You know, so just essentially making the problem transparent to everyone. You know.
What's the flag?
So Mothers Out Front has had and maybe still do a campaign where there's a leak, they just plant a yellow flag and it has a sniffing nose on it, and it basically makes it clear that there's a leak there.
We did it in a concentrated time period, and then we collected the flags back again.
Yeah.
But during that process, a lot of people talked with us and were reading the information that we left attached to the flag.
Did the
flags.
utility companies respond to those flags at all, per se?
Not in any way that we know. Audrey might know a little bit more. We didn't do any measurements. We were just going from the mapping that had been done. And we were given points where there was more significant leakage going on.
And so that was actually driven by information provided by the utilities. But like a follow-on development of this could be, you know, because we know the leak map provided by the utilities, as good as Audrey did to put them, you know, faithfully down where they were looking, the utilities get it wrong sometimes. Or these missing leaks, or what are we calling them?
Yeah,
Missing leaks, you know, that have come off the books. And, you know, it doesn't seem like they, you know, like 15% of them came off like on December 31st. It doesn't make sense. So it's kind of auditing, you know, them as well. And this is just us being parked here, okay? So you can see it going up and down and up and down, and that, again, is just the wind wafting this leak around. So it gives you an idea of the vagaries of the weather conditions, but you can see also that even when it goes down, I mean, it's still, the lowest it ever went here is like, I don't know, 2.7 or maybe 3 or so. So it's obviously a leak. But depending on the conditions, I mean, we were up above 16, we were down to like 3, you know, and so if you drive a leak 2 different times, you're going to get 2 different peak readings. And that's part of the thing that makes it difficult to estimate, like, really how big the leak is. This is still the Swiss Alps of leaks. Okay, here's the school.
What are you at?
243. Okay, so there's a leak right here at the school. 237. So when you see it dip down like that and then come back up like that, that's pretty clear. We're moving at a steady pace here. So yeah, we've got a leak here. I didn't pay attention to the trees. 4. Okay. Some young trees.
30.
Patches.
38.
4.
29. Somerville.
Okay, that tree
planted a whole bunch of new
2
trees.
They are just gonna get killed, huh?
A lot of money.
All right.
2 0.
So leaks there. 9.
9.
We got 9.
I don't-
11.
11.
Okay.
Whoa, let's
So
pull over.
you want to pull over?
Yeah,
Okay.
And you see the yellow markings everywhere.
and that's always gas. The yellow is gas.
Yeah, yellow always refers to gas.
Oh.
Blue is water.
So it's like you
No,
see
it's not. I
stuff
can look it up.
every time that's just a little different. Like, I don't know if I've ever seen a marking like right on a curbstone like that for
Yeah, it's interesting.
CI, you know, and I guess that's the arrow of it going.
Yeah, but there seems to be one here too.
Right.
So are there 2 12-inch mains running down this street that way?
You can have
underneath
multiple
us?
mains, you know, and oh, I think they're bracketing it here. If I'm, so you can see the 2 yellow lines, but here it is, 12-inch cast iron. Cast iron is the old leaky stuff. It's the most leak-prone most prevalent leak-prone pipe.
So with cast iron, the way they originally did it is they put jute, which is sort of a grass between the two joints, you know, to close the joints. And then as the gas got less humid, because they decreased the humidity of the gas, that jute dried out.
Interesting.
And so they're basically almost all cast iron has problems every 12 feet because of that.
Wow.
Let's see if we get anything out of here.
Nathan and Bob Ackley went out to
All that work and we got nothing.
and,
Okay,
so
so it's not in there, but
maps of what it looked like at that time.
now these are drill holes. So just kind of push it there and see if you get anything. Just hold it down. You'll hear it slow down. The pump slow down if you push it too hard. Okay, nothing there. So that drill holes are for the gas company when they come out. Electricity.
Funny.
It's like it vanished.
Okay, let's come out quick and try these. All right, so let's go out here and let's just test. Let's stick it in one of these things real quick. Leave it in for about 10 seconds. And maybe someone can make sure we don't get hit.
Yeah.
Keep an eye out. Okay, so
yeah,
okay.
There we go. 40.
0.4.
Now, is it coming from the soil?
Keep it in there. Keep it in there. Okay. Okay.
Car's coming.
All right, we can get up there. Okay, so definitely gas in there. Okay, so yeah, we didn't really find. I mean, we found the leak, but we didn't find any large concentration.
It might have been a little further down the block.
Yeah, I mean, it's all along this block, so yeah. This is relatively new, right? Look at the line where the new paving was. This intersection was redone with a new everything. We got gas, so this is an example of a lost opportunity.
With MAPC, he did a study to sort of figure out how much municipalities and gas companies could save by doing sort of more integrated infrastructure repair and not screwing up like this.
Here comes a yep.
And it was like $1 billion. So for you can check it at fixourpipes.org. It's a really
More
beautiful
gas.
website.
So there's just a little bit, but there is gas. I mean, so that's not good.
So you can sort of imagine like all the infrastructure underneath, both the gas pipes and the electric and the water mains and stuff like that, and it's as well as the paving, and the paving alone in Massachusetts, I think it's $600,000 on average per mile. So it's just expense layered on expense on expense. And so if you change if you fix anything, if you cut into the pavement for any reason, you should just fix all of it at the same time. Because otherwise it's like operating on somebody's appendix and finding a broken artery and be like, oh, whatever. Forget that. We'll, take care of that some other time. Not our responsibility.